Chapter 5, Section 4 is the triangle midsegment theorem. First off, we need to know what the midsegment of a triangle is. And it's a segment that joins the midpoints of two sides of a triangle. Okay, so right here we have triangle ACE. B is the midpoint, so I can write this congruent to this. D is the midpoint. These two things are congruent. F is the midpoint, so this is congruent to this. Okay, and so the midsegment of a triangle would be when I draw from B to F. So BF is the midsegment. Now, if I draw all three of them, I form the midsegment triangle. Okay, and I'll do that here in a sec. But first things first, I've listed the length of AC here, and it's 12.85. I've listed the length of AE, 13.88, and I've listed the length of CE. Okay, the theorem for the triangle midsegment says that the triangle midsegment theorem, a midsegment of a triangle, is parallel to a side of the triangle, and its length is half of that side. So, when I draw the midsegment theorem, that means BF is parallel to CE. And since it's the midsegment, then that means BF is equal to half of CE. So half of CE, so CE here is 15.74. Half of that is 7.87. And so I took the measurement of BF. And BF is 7.87. Okay, I could do this with all of them. If I draw the segment for BD, then that means that BD is parallel to AE here. Okay, it's parallel. And that means that BD is going to be half of AE. Okay, so AE is 13.88. I take half of AE, I get 6.94, which BD is 6.94. I can do this again with this segment, this midsegment. So FD is parallel to AC. And since they're parallel, and this is the midsegment, that means that this length is half of AC. Well, half of AC is 6.43. And FD is 6.43. All right, and this triangle BDF is the midsegment triangle.